There we go. She's going to put the start of the class word. So let us begin. So identify the correct Lewis dot structure for nitrogen, which is in group 15 on the periodic table. Remember, group 15, that's going to tell us that there are 5 valence electrons. There are 5 valence electrons. So we got to go ahead and do our Lewis dot structure. Remember, our Lewis dot structure goes first all the way around, and then we start pairing them up. So if you look at this one, exactly, it was what Mrs. Larkin said. We have 4 here, so this can't be it. 6 down here. So these 2 are a no-go. And let me switch my color. This is a no-go. This is a no-go because we're looking for 5. Now, these 2 are a possible answer. But if you look at this one, the reason why we chose this one is because that if you look at it, you have 1, 2, 3, 4. You go around the element first, and then you start pairing up to 5. This one still needs to go around the element first before you start pairing. Okay, that's the difference between these 2. Each side is filled before pairing. Beautiful. So who is someone that you look up to? I love it. Looking up to someone is extremely important to keep it positive in your life, to kind of show you what is good choices, what are bad choices. So again, my mom, my dad, my pops, or my papas, excellent. I love it. Nice job, Anthony. Again, let us know in the chat box, parents for sure. Yeah, I would say my parents, but you know what really kind of inspired me and I really looked up to was my science teacher in high school. Can you believe it? Look at where I'm at now. So again, it was my science teacher that kind of inspired me to be a teacher, because in the beginning here, I was a history teacher. Now I am a science teacher. So again, older brothers, sisters, absolutely. It's important to have that role model in life and to have that guidance as we go through our life. So let's go ahead and move on. It's great to see that. Remember, our Class Connect sessions are recorded and distributed for learning purposes. Please do not put any personal information into the chat box for your protection and the protection of others. Make sure you're participating. It's extremely vital and is expected. As you are participating, make sure you're respectful and school appropriate at all times. Oh, that's so nice, Shelb. Thank you. So here is your attendance now. So our attendance is in the chat box. When you got your attendance, go ahead and quickly raise your hand. It should be a pretty easy word to get there. Raise your hand for your attendance. Again, we do have that if you are not participating. Okay, if we call your name multiple times, we will dismiss you from class from non-participation. So please make sure you get your hand raised. We'll check in with you first, but please make sure you raise your hand. All right, so we have our beginning of the class word for the first 15 minutes of class. After that, you do technically have until midnight tonight. So if you need to, copy the word down, make sure you spell it correctly, and complete it a little bit later. So let's go ahead, and I'm going to only give us about 20 more seconds to get that up. I'll get that timer up, 20 seconds. Let's go, go, go. I'll see your green check into the chat box. 7 more seconds to get our hands raised. Thank you, Ame. Again, if you are having issues, if your computer's slow or what have you, just let us know. All we're asking for you is to communicate with us, okay? Just communicate with us what is going on so that we know you're still here, that you're still participating. It's just that maybe you're having tech issues or that you're working on your phone. All right, here we go. Thank you, Stephen. No worry, Ignacio. If you can go scroll up, Ignacio, you'll find the beginning of the class word. All right, so let's go ahead and check in. Moses, Monique, Eric, Catherine, Kamari, Christopher, Canyon. Thank you for those. Thank you, Kamari. Thank you for Patrick, Ignacio, Jaden, Canyon. Oh, it's moving on me so fast. So let me go through this. Moses, Monique, Eric, Catherine, Christopher, Jaden, Ignacio. Let's get our hands raised. Thank you so much, Christopher. Last call, Gabriel. Thank you, Gabriel. Moses, Monique, Eric, Catherine, Jaden, Ignacio. Let's get our hands raised. Thank you, Gabriel. I saw your hand raised. Excellent. We'll go ahead and check in with those few people. So as we are checking in, let's go ahead and go through our schedule. Today is day 28 of our 60-day adventure. It is Friday, January 15th. Today we're going to talk about polar covalent bonds. We're going to do this through our 3D slides in our Chemistry Unit 3 Friendship Project. So with that, as we look here, we're still on track for January 21st as our due date. This is a pretty short unit. So again, January 21st is probably set in stone. At this point, it is a very short due date, or short project. So we're going to go ahead and probably set that one in stone. So look out for that date. Write it down if you need to, but that will be the date for turn in. All right, today we're going to define electronegativity and apply the concepts of types of bond. We're going to explain how partial charges are formed in a polar covalent bond. We're going to use that Lewis dot diagrams to demonstrate the formation of a polar covalent bond. And we're going to do this all through our slides 28 and 32.
All right, looking good. So at this point, I need you all to go ahead and open up your project. Mrs. Plovit, I sent those names to you in the chat box for you. Let's go ahead and get that open. If you started it in the Google Slides folder, here is the link to Google Slides folder. Go ahead and open it up there. If you started in PowerPoint, obviously open it up on your computer. If you have not yet started, I need you to go ahead and go to your Grades tab and download the template. We are over halfway through this project, and again, we do every slide together, either in class. We do all the note slides, or we do those project slides on project work days. I post a recording, or we work on them in class. So we do everything together. So we should be getting really good grades on these projects. We should be learning a lot from them. Yeah, we're almost done with it, right, Shelbs? All right, go ahead and raise your hand once you have it open. Again, if you're downloading it, go to the Grades tab, scroll down to where you see the Toy Story picture, and then download either the Google version or the PowerPoint version. Alternatively, if you want to take pictures and fill it out later, that's fine, as long as you fill it out later and still raise your hand when you are asked to let us know that you're ready to move on, even if it's technically not in your slides. Awesome. Yes, I totally understand, Shelby. That is why we upload those recordings. That's why everything's in the recordings. We want you to have those resources. Fast forward, rewind, go to where you need to, pause it, do whatever you need to in those recordings. Excellent. All right, I see Annabelle and Stephen in the chat box. I'm still waiting on Gabriel, Moses, Derek, Daniel, Monique, Eric, Catherine, Angelo, Kamari, Christopher, Aria, and Patrick, Taylor, Kale, and Jaden. Please raise your hands. A couple of you, this is your second chance to check in with us. Again, if you do not check in with us after 3 tries, we'll go ahead and dismiss you and you won't be able to get that end of class attendance. We don't want to do that, so please make sure you're chatting with us. Please make sure you're responding. Remember, our basic requirement is please raise your hand. That's our bare minimum. You have 20 more seconds to get your projects open and respond. Thank you, Gabriel. I see you in the chat. 10 seconds. All right, Monique, second chance. Monique, Catherine, second chance. I need your hands raised, or you need to be private chatting us back, please. Mrs. Pelota has private chatted you. Please respond. Waiting on Kamari, Jaden, second chance. Jaden, and Kamari. This is your first chance. Kamari, make sure you're responding. Hello. I know your hand raised earlier. Okay, perfect. Thank you. Looking good. All right, so it looks like Kamari, you're my only one then that has not yet been done. All right, let's go ahead and lower these hands and let's keep on moving, everybody. All right, so what I want to know, first things first, is what is something that you find difficult to share? I promise you this is related to our lesson, albeit a little bit extrinsically. Go ahead and tell me in the chat box, what is something that is difficult for you to share, maybe with your siblings, with your parents, with your friends or family? Something difficult for you to share. I know, for example, yeah, Cold Stone ice cream, right? So ice cream, stuff, angst. I know a lot of other students said feelings were hard to share. Yeah, chips and cake and ice cream, everything. What other things are difficult for you to share? Belongings in general. Yeah, my family, my husband and my daughter food tax me a lot, so they take bites of my food. And my daughter especially takes huge bites. I'll be eating ice cream and she's just like stuffing it into her face. And I'm like, this is too much. This is too much, my child. All right, awesome. I'm seeing, let's see here, what else? Attention, hard for you to share attention. That's funny. Your phone, absolutely everything. You guys are funny. Well, okay, so far we've talked about ionic bonds and their friendship, which is where they actually give something to somebody. We've talked about nonpolar covalent bonds on Wednesday, which is where they share perfectly and equally with each other because they're twins, they're identical, they love each other a lot. Today, though, we're going to talk about Okay, no worries, Miles. Yep, just checking at 12. So today, though, we're going to talk about what happens when they share, but they don't share very well. Much like me and my ice cream with my daughter. What happens when we don't share very well? So this is going to lead us to our topic for today, which is polar covalent bonds. But before we get to that, you know it, I know it, we have to review electronegativity. I know it's your favorite. So electronegativity, again, is the ability to attract electrons. Again, it's how cute atoms are. And remember, atoms are cuter or more attractive to electrons when they're smaller, much like how puppies are cuter than the grown adult versions of themselves. And again, the whole reason behind this is because a smaller atom can reach out and attract an electron better. All right, think about that. Nucleus is made up of positive protons. It's going to be easier for it to get outside of itself and attract something if it's small. The bigger it is, the more shells it has, the more it's got going on, the harder it is for it to reach a new electron. So the smaller you are, the more electronegative. We know that. Now, again, reviewing the trend, as we go to the right in the periodic table, we actually end up being smaller and therefore more electronegative. So if we take a look here, good old fluorine is the most electronegative element on our periodic table. Your dog is always cute. Right, I totally agree. I think dogs are always cute, but I definitely think puppies have that special little element to them, right? So as we go to the right, we can see fluorine gets smaller. Now the reason for this is because in a period, remember that their shell structure is actually the same. So if you take a look at lithium all the way to fluorine, they all have two shells. Let's take a look here at carbon and nitrogen, for example, have two shells. The only difference is as you go to the right, you're adding more protons to that nucleus. And as we add more protons to that nucleus, that makes it more attractive, right? It's got more positives to attract the outermost valence shell, and so it's going to shrink in that valence shell, making it smaller, and again making it cuter and more attractive, more electronegative. Smiley faces, emojis, yeses in the chat box if that's making sense so far. All right, this is all review, but we need this in order to have a firm foundation for what we're talking about today. Beautiful. Now in groups, electronegativity still is better when you're smaller, but this time you're smaller near the top of the group, the column. All right, and this has to do with the number of shells. Remember, fluorine is in period 2, so it has 2 shells. As we go down, the periods increase. So now we have 3 shells, 4, 5, and 6. And the more shells you have, the more shielding you have, the more baggage you have. It's harder for that nucleus to reach outside of itself and try to get a new electron. Take a look at this potassium here. He's got to get through 4 shells just to try to get a new electron. That's going to be really hard for him to do. Now, the exception here is hydrogen. Hydrogen, you'll know, is the smallest atom on the periodic table, but it is not the most electronegative. And the reason this has to do is with the shell that hydrogen has. So take a look at lithium, sodium, and potassium. Take a look at their smallest shell. That smallest shell does not fit 8 electrons. It only fits how many? Tell me in the chat box. Analyze the picture, zoom in if you have to. How many electrons are on that smallest shell for lithium, sodium, and potassium? This is true for all of them. I see Gabriel in the chat box. Need more participation? Take a look here at the smallest shell. We're analyzing the smallest shell from the pictures. Yeah, they can only fit 2 electrons on the smallest shell. So smallest shell only fits 2 electrons. That's different. That's kind of our exception to our octet rule that we've been talking about. So that being said, hydrogen has 1 out of its 2 valence electrons, which means it's actually only halfway filled. And tell me in the chat box, what is the way that we write the percentage for halfway? From 0 to 100%, which percentage is halfway? Go ahead and tell me in the chat box. Another way of saying it's half full, it's what percent full? Thank you, Stephen. Thank you, Shelby. That's a decimal form, but that still works. Absolutely. What is the percentage of halfway? Perfect. So what this means is hydrogen, oops, that's all caps. Hydrogen is 50% of the way full. Now, every other nonmetal has the ability to have 8 valence electrons in total, and they all almost have 5, 6, and 7 of those 8 electrons already. So taking a look here, that means that, for example, fluorine is 7/8 of the way already filled. So 7 divided by 8 gives us a percentage of 87%. So fluorine is actually 87.5% or 7/8 of the way full. And so fluorine's actually closer to being full, and so therefore fluorine is more desperate for electrons than hydrogen. All right, fluorine is so close to being full, it's going to actually be more electronegative. It's desperate to finally fill itself up. Smiley faces, emojis, yeses in the chat if all of that it makes sense. Again, hydrogen is the one exception to this rule because we're going to take a look at hydrogen later today in action. Thank you, Ame. What is that? Is that milk? Looking good. I see the alien from Shelby. Perfect. Looking good. All right, so that leads us to our overall trend, right? Fluorine increases as electronegativity increases to the right, increases as we go up, making, whoa, calm down. Making, I don't know what happened here. Let me clear this page. Making these nonmetals the most electronegative elements on the periodic table overall. They're the most electronegative. Again, hydrogen is technically a nonmetal, but a little bit less electronegative because of that halfway issue. So that's kind of synthesizing it all together. Now, let's go ahead and apply this to our bonds. I know, my text tools just went nuts. So we have already learned about two of these bonds. We've learned about ionic and nonpolar covalent. Today we're going to be learning about polar covalent. Now, so far we kind of had very stiff definitions for what each of these are, but the reality is that bonding is kind of a spectrum. It's not perfectly delineated, meaning perfectly boxed up into these different definitions. Essentially, it has to do with the difference in electronegativity. So it's not perfect. So ionic bonds, that's what we talked about on Tuesday. We said there's a huge difference in electronegativity in ionic bonds. And this should make sense because we actually have two completely different categories. We have a metal with a nonmetal. Metals, we learned previously, have low electronegativity, and so they lose electrons, whereas nonmetals have high electronegativity, and so they actually gain electrons. And so the result is we end up with ions, right? Taking a look here, we end up with the positive ion here. Remind me in the chat box, positive ion is called a what ion? It's not a dog ion, it's a what ion? Go ahead and tell me in the chat box. Positive ion. There we go. I see Shelves got it. Keep on participating in the chat. Positive ion is called a what? It is called a what? Thank you. Yes, it's a cation. Exactly, cation. So because this cation completely gives an electron over to the other atom, it becomes positively charged, and the other one becomes negatively charged, making it a what? What is the opposite of a cation? Also like the anti one. What is that one called? Thank you. Yes, beautiful. It's the anion. Perfect. And so now they're opposites, now they're attracted. That is what we learned about on Tuesday. Let's go ahead and actually take a look at it in action. And I'm going to go ahead and also share this with you in the chat box. All right, so let's go ahead and take a look at this. If you want to play around with the demo, I apologize, you can't play around with it while we're in class. It doesn't work like that. So let's go ahead and take a look here. So we have right here two atoms, and this time we're going to see what happens when one of them has very low electronegativity, that's our metal, and one has very high electronegativity, that's our nonmetal. So we have the yellow metal, the green nonmetal. Taking a look here, again, they have really big charges. One ends up being a really big positive, that's our cation. One ends up being a very big negative, that's our anion. They're attracted, and therefore they are bonded together. Smiley faces, emojis, if that makes sense. Smiley faces, emojis, if you feel comfortable with that. This is a more ionic bond. Again, it's kind of a spectrum. This is going to be more ionic. Great. Let's go ahead and then jump back over here and take a look at the other one that we already learned, which is nonpolar covalent. All right, so nonpolar covalent has no difference in electrons. Remember that this comes from between nonmetals. Again, covalent sharing only happens between nonmetals, but specifically identical nonmetals. It doesn't matter if the nonmetals have high electronegativities or low electronegativities. If they're the same, equal, then there's no difference, and therefore they have equal sharing. Nobody becomes positive, nobody becomes negative. Let's go ahead and check that one out. So I'm going to share this one with you up on the board. All right, so let's take a look here. If they both have low electronegativities, do you see any charges? Yes or no? Do you see any charges happening? Any ionic charges? Thank you, Annabelle. Thank you, Daniel. Thank you, Shelbs. No, exactly. They are completely sharing. This makes it highly covalent. You can see that on our scale down here, which makes it non-polar. Perfect sharing. Now, even if they're both medium, Again, it's still perfect sharing because they have identical, no difference between their electronegativities, and even if they both have high electronegativities, if they're the same, they will still be perfectly covalent, perfect sharing. Now, what do you think was going to happen with our, let's go ahead and take a look at our, where'd my playlist go? Come on. Let's go ahead and take a look at today's then. So we've taken a look at a large difference, no difference. Now we're going to go ahead and take a look at a small difference. Dipole means like polar, means they have different poles, positives and negatives, like polar opposites. Shelby. Shelps. All right, so this time we're going to take a look at polar covalent. This time they're going to have a small difference. Again, it's still covalent, so we discussed covalent the other day, only happens between nonmetals, and so they're going to have they're still sharing, but this time they're sharing unequally. Think about again the like me and my daughter trying to share ice cream. We don't do it well, right? So we are sharing, we're just not sharing well. So one of the atoms is slightly more electronegative than the other, so it's going to pull the electrons a little bit closer to itself. Now, before we start practicing this, let's go ahead and fill in the blanks here. Sorry, this is a good diagram here. Again, it's a spectrum. You either have low electronegativity difference, making you nonpolar, slight difference, making you polar, or completely different, making an ionic bond where we transfer electrons. Let's go ahead and work on slide 28.
About how ionics are large differences, okay? And so I'm going to go ahead and put that up there. So these are large differences in electronegativity, whereas polar covalent is going to have small differences, and we're going to talk a little bit more about that one. Okay, this one's going to be small differences. So I'm going to put that one right there. And then finally, our non-polar covalent is going to have no differences. Okay, no differences. Remember, they are perfectly, in a perfect world, perfectly equally sharing that electron. Okay, so these are 3 of your blanks on slide number 28. I'll go ahead and give you, let me go ahead and clear these hand raises out. We're going to give you, let's say, 30 seconds to get these in. 30 seconds, raise your hand when you are finished. Go, go, go. You're in there too. I don't know if you're just making your cute little kitty. Stephen, thank you. 10 more seconds, 10 more seconds. Thank you, Ame. Eric, awesome. I don't know how you all make these cute little animals. All right, let's go ahead and check in with others. Thank you so much for letting us know. So Gabriel, I see you in the chat box. Alberto, raise your hand. Monique, Catherine, Angelo, Kale, thank you, Alberto. All right, let me just give me a quick second while everything calms down. So Monique, wow, this moves way too fast for Monique, Catherine, May, I see you in the chat box. Christopher, Shelbs, I see you in the chat box. Jaden, Miles, Stephen, thank you. I know you're in the chat box. Tayan, thank you, Miles. Thank you, Alexis. So Tayan, Jaden, Catherine. I think you're my last one. Let me see if, let's see. Patrick. I don't know if you're in the chat box, but let me know. Patrick. Jaden, you're my last 2. Patrick, Jaden, Catherine, actually last 3. Let's get those hands raised. Hands raised, please. All right, we're going to go ahead and move on. I'll check in with a few people.
Okay, so this one is easy peasy. Again, we kind of already discussed it. Polar covalent bond has a small difference in electronegativity. We end up sharing unequally. So one nonmetal is slightly more electronegative than the other. It's going to pull those shared electrons a little bit closer to it, but it cannot completely take them. Again, it's like a tug of war, but kind of like a bad tug of war where one person's winning but never wins completely. All right, that's like your worst nightmare with a tug of war, right? So this makes it not symmetrical. And again, this is where the word polar comes from. We talked about polar meaning polar opposites, right? Polar opposites. And so now that we are talking about polar covalent bonds, covalent still meaning sharing, but polar meaning they're not symmetrical, they are unequal. And we're going to see in a moment they end up with some slight charges, not enough to be ionic, but they do end up with some partial charges. Hydrogen ends up being slightly positive here, chlorine ends up being slightly negative. This is going to go ahead and be slide number 30. Here we go.
Okay, don't worry. So slide number 30 is going to be obviously slightly more. So it's going to be closer. So the electrons that are pulled are going to be shared, and those electrons are going to be closer. So this is the answer to number 30. I'm going to go ahead and lower your hands. Do we lower our hands, Mrs. Larkin? Perfect. All right. So these are good hands. So let's go ahead and give you, just because it's one word, we'll give you about 20 seconds. 20 seconds up on the clock. Go, go, go. Let's see those hands raised. Let's get 100% out there. Don't worry. Perfect, perfect, perfect. Again, if I call you, just let me know. Just remind me. Again, 10 more seconds, 10 more seconds. All right, so looking for a couple of people. Catherine, last call. Catherine, Kamari. Aria. Patrick, I see that you're responding. Just go ahead and raise your hand. Thank you so much. Jaden. Stephen, I see you in the chat box. Ooh, it keeps moving on me. Keeps moving. Sorry so much. Adriana. Annabelle, I see you in the chat box. Stephen, I see you in the chat box. Jaden. All right. Thank you. All right, let's go ahead and move on.
All right, so let's go ahead and actually practice this, okay? So a nonmetal that is more electronegative, what do we think it's going to become? Slightly positive or slightly negative? Let's talk about this. Remind me again, in the chat box, electrons have what charge? Are they positive, negative, or neutral? Again, we've talked about protons, neutrons, and electrons are in atoms. When we talk about bonding, we're talking about electrons. Yes, electrons are negative. Electrons are negative. They are negative, okay? So that being said, if one of our nonmetals is more electronegative, it's going to pull those electrons slightly more, right? So it's pulling negative electrons towards it. So what do you think it's going to become overall? Slightly positive or slightly negative? Slightly positive or slightly negative? Go ahead and tell me in the chat box. Again, thinking about how it's pulling negative electrons towards it. Like if you pull negative friends towards you, do you become overall slightly positive or slightly negative? If you pull those friends towards you, pull those negative friends towards you. Okay, there we go. Looks like we're correcting our misunderstanding here. Yeah, you actually become slightly negative. All right, again, you always want to think about, I know it's hard to think about because electrons are oppositely charged, but remember that you're pulling negativity towards yourself. Towards it. It's pulling negativity towards it. So that actually makes it slightly negative. In this case, that's going to be our fluorine. Fluorine, again, is the most electronegative on the periodic table. Now, hydrogen, on the other hand, is less electronegative because, again, it's only halfway filled. We talked about that earlier. And so this one is less electronegative. It's losing its negative electrons. Like if you lose negative friends, your life becomes slightly what? If your negative friends are further away from you, you become slightly more what? Thank you. I see Ignacio. I see Alan. I see Daniel and Camilla and Annabelle. Thank you. Yes, you actually become slightly positive. And that's because those negative electron friends are further away. Now, you'll notice that there's kind of these funny symbols here. These are called lowercase Greek deltas. So it looks like a letter D, but it's a Greek D, basically. And so this stands for partial. So hydrogen is partially positive and fluorine is partially negative. I'll give you a heads up that in almost every instance of hydrogen bonding with another atom covalently, it's almost always the partially positive one because, again, hydrogen is less electronegative than almost every other non-metal. Smiley faces, emojis, if you're feeling good about that. All right, perfect. Okay, so let's go ahead and work on slide number 31.
Slightly negative. So this one is going to be slightly negative. Okay, slightly negative. And then as we talk about our non-metals that are less electronegative, they become slightly more positive. Okay, positive. Excellent. So there are those your 2 words for slide number 31 on the left-hand slide. Slide 31, again, give us a raise of the hand. I'm going to give you only about 25 seconds to get that done. 25 seconds up on the clock. Go, go, go. Let's get 100% on this. Let's raise our hands. Let's get 100%. Thank you, Stephen. Thank you, Annabelle. We see you up in the chat box. Excellent. 100%. We're at 10 seconds. 10 seconds to go. 10 seconds to go. Digital high fives for that 100%. Let's go. I'm gonna start singing. You don't want that happening. All right, here we go. So Kamari, let's get our hands raised. Christopher, Kale, Jaden. Last call, Jaden. This will be your last call, Jaden. I've checked in with you. No answer, Jaden. Thank you, Stephen. Ignacio. Don't be eating your Sonic now, Ignacio. Annabelle, I see you in the chat box. Adriana, and then Alexis, Adriana. Let's go ahead and get our hands up. You're my last two. Ignacio. All right, let me go ahead and check in with those few people. Thank you so much.
All right, so we talked a little bit about how to do Lewis dot diagrams on Wednesday. Today we're going to go ahead and practice it between atoms that are different, specifically hydrogen working with your non-metal. So we're going to have an example of a group 17, group 16, and group 15 because those are the 3 options in your project. So this will help you with your project analysis for chapter 3. All right, so that being said, let's go ahead and take a look here. We're taking a look at what happens when a non-metal bonds with hydrogen. And so hydrogen has 1 valence electron to share. Remember, it only needs 2 in total because of that smallest shell issue in order to be happy. And if for some reason your nonmetal needs more valence electrons, you can always just add additional hydrogens. So let's go ahead and practice this. What I want you to do, grab your whiteboard tools, grab your colored arrow, and point for me, where are these atoms going to bond together? Where is the pair that I need to match up? Where are the electrons that I need to match up? Go ahead and point for me on the board with the colored arrow. Where are the atoms that I need to match up? Good, there's one. And where's the other one? Go ahead and get more people up on the board. Where are we matching up the electrons? Thank you. I see a purple arrow. I see a pink arrow. I see a green arrow. All right. So we've identified 1 valence electron. It's going to match up with which other one? Think about it's bonding with hydrogen. So where's the other valence electron it's matching up with? Where is the other valence electron it's matching up with on a hydrogen? There we go. Perfect. Yes, awesome. Let me go ahead and pause those tools. So taking a look here. So this one is going to match up here, and this one's going to match up here. So we end up with 1 pair, right? So we end up with 1 pair shared overall. And so I'm going to draw that as a line. So here's a hydrogen. Here's bromine. Again, I'll keep bromine's other electrons the same. And in the center, I'm going to draw that line. Now, this line, again, counts as 2 shared electrons. So, is hydrogen happy? It has 2. It wanted to. Is hydrogen happy? Yes or no? Based on what we said, hydrogen wants to. It has 2 shared. Is it happy? Yes or no? Thank you, Shelbs. Thank you, Annabelle, Anthony, Camilla. Yep, hydrogen's happy. What about bromine? Bromine's got 2 on the top, 2 on the right, 2 on the bottom, and 2 from this shared pair. So 2 plus 2 plus 2 equals what? 2 plus 2 plus 2 plus 2 plus 2 equals what? Yes, Ignacio. Yes, Camilla. It has 8. And does that satisfy the octet rule? Is bromine happy? Is bromine happy? Yes, it's happy. Bromine's happy. Now, again, hydrogen here is less electronegative. It's going to lose the tug of war on those negative electrons. So hydrogen should become slightly what? Slightly positive or slightly negative? If it's losing negativity, it's losing those negative electrons. It should become slightly. Thank you, Shelbs. Thank you, Alan. Perfect. Annabelle, Gabriel, Stephen. Yeah, it actually becomes slightly positive. So I'll draw that delta. And bromine, on the other hand, is winning them. It's gaining them. And so it's going to be slightly negative. Smiley faces emojis if you feel a little bit more comfortable now that you've seen it in action. I would love to have you draw it, but I think that might get a little bit messy up on the board. So we'll just deal with pointing for now. Cool. All right, let's go ahead and fill in our...
The other nonmetals need more valence electrons. You add additional hydrogens, okay, can be added to the compound. Additional hydrogens can be added to the compound. Let me go ahead and put that up there. Additional can be added to the compounds. Go ahead and lock in your answers. Again, it's only one answer, so we're only going to give you 20 seconds. Time is of the essence here. 20 seconds. Hands raised. Let's get 100%. Thank you, Annabelle. Thank you, Stephen. Let's get those hands up. Raise them high. Obviously, we can't raise them too high. It's just a little digital man. But, you know, it's all right. I know what you're talking about. 2 seconds. 2 seconds. The word additional in the blank there. All right, here we go. So let's check in with everybody. So Gabriel, raise your hand high. Kamari, Aria. Patrick, I think let's see, I think we're good. Patrick, go ahead and raise your hand. Let us know. Thank you so much. Stephen, we're good. Alan Tayan. All right, we're moving a little bit, so just give me a quick second. Adriana, last call. Adriana, Annabelle, I see you in the chat box. So Gabriel, Kamari. I think Gabriel, I see you. Are you in the chat box? So we're just looking for, thank you so much, Gabriel. Kamari. Let's get our hands raised. I think we got it. I think we have 100%, Mrs. Larkin. Digital high five, double high five. Yay! Nice job, everybody. Woohoo! Here we go.
I love it. All right, let's go ahead and practice the last two examples with a group 16, group 15. Again, depending on which nonmetal you chose for your project, you're going to use whichever of these examples makes sense for that. So taking a look here, go ahead, point for me up on the board. Where is the other pair that I need to match up? So I already have one shown for you. Where's the other pair that I need to match up here? On the X. We're over here on the X, guys. On the X. There we go. All right, got a couple people up there. Thank you. Perfect. Looks like we're in the right area. Awesome. Yes, we're going to go ahead and match up these ones right here as well. So this time we have two pairs, so we should end up with two lines. So here's my X. I'll keep its unpaired electrons the same. Here's the hydrogen and the hydrogen. All right, so they have two shared between them on each line. And X has two up here. So taking a look here, are the hydrogens happy? They each have two electrons being shared with them. Are they happy, yes or no? Are they happy, yes or no? They should be happy, right? So hydrogen has two and wanted to, so hydrogen's happy. This one's also happy. Taking a look at the X, now the X has two on the top, two on the right, two from each shared pair, so 2 + 2 + 2 = 8. Is X happy as well? Our group 16. Yes, this one is also happy. And again, X is going to be slightly more electronegative, so it's going to become slightly negative. Hydrogen will become slightly positive. Now tell me in the chat box, how many bonds do you think we'll end up having in this one? Go ahead and let's take a look here. How many pairs, bonds will we end up with? How many lines will we end up with for our group 15? Thank you. I see Shelbs. I see Camilla, Annabelle. Can't even trick y'all. You are too fast for me. So yes, we'll go ahead and match these up. Again, I would have you draw, but I know it's a little bit hard with all of us on the board. So let's go ahead and match those up. And so we have our Y with its two electrons on the right, in addition to a line of hydrogen, a line with hydrogen, a line with hydrogen. Again, each line counting as two. So this time each hydrogen has two, and our Y has 1, 2, 3, 4, 5, 6, 7, 8. Everybody's happy. Again, Y being slightly more electronegative, and the hydrogens becoming slightly positive. Smiley faces, thumbs up if you feel comfortable with this. Again, these references are in your slides. Let me know if you feel comfortable with being able to do this on your own for your own element. Great. Well, that being said, let's go ahead and check that out. I'm going to go ahead and sorry, this is from an old part. So these references can be used for chapter 3. So again, if you have a group 17, you'll use the Br example, the bromine example. If you have an element in group 16, you'll use the X example. And in group 15, use the Y example. So group 17 bonds with 1 hydrogen, group 16 bonds with 2, and group 15 bonds with 3. So we already did the examples together. You should be able to apply that to your own project today or on a project work day, okay? All right, so let's go ahead and take a look here. Again, here are the cleaned up examples for your use. For the project, chapter 3, you're going to be taking a look at your nonmetal bonding with a hydrogen. So you'll explain how is your nonmetal stronger or more electronegative than hydrogen. How does your nonmetal try to share with hydrogen but isn't as good at sharing because they're too strong? And how does this still result in friendship? So even though they're maybe not be the best at sharing, at least they're trying. All right. And then talk about how that is related to polar covalent bonds. Again, you have the sentence framework here, so make sure that you fill that in. If you want to, you can always delete that and rewrite your own story if you want to be more creative. Again, we will have more videos for you for this on Wednesday, which is your next project work day. And then you'll analyze it. You'll talk about how many valence electrons each of your nonmetal and hydrogens want to gain. Therefore, how many hydrogens do you need and what would be the final chemical formula? Again, we already did this together with a group 17, 16, and 15 element. All right, let's go ahead and wrap up.
You were able to define electronegativity and apply the concept of types of metals. You explained how partial charges are formed in those polar covalent bonds. And then we use that Lewis dot structure to kind of demonstrate the formation of those polar covalent bonds. We did this all through our slides. Again, if you do need to go back this afternoon, we'll have our recording up. You can go back and get those slides if you missed anything at all. All right, at this point, I feel like we are pretty good. So let's go ahead and stop our recording. Boom. And then we'll stop